All right, everybody. I want to thank you for taking the time here on your Friday afternoon to spend with us. Hope you all enjoyed the new edition of the photos, not only from here around the plant in Fultonville, but also of our global team out seeing customers and at trade shows, giving you a little bit more of a flavor of our team here. That'll be something we're going to try to do on these different WebEx events so that you guys get a better feel of our team here. So to kick us off and get started, I wanted to really bring us back to the mission statement. I know this is a big part of what we typically kick these WebEx events off with, but I think with today's topic, this is particularly important because most of these design methodologies that we're talking about are truly focused around making the right sensor for our customer. So a big part of that is this sensor solution focus that we have, making sure that whatever the product is that we're providing to our customer truly meets their need, and the focus specifically on dairy, food, and the pharma biotech industry brings with it some unique challenges. So we'll talk through kind of those robust differentiators. So as you guys think about today's discussion, it's really about the things that make the Anderson-Negele product unique, and it reaches across a number of different products as we're talking here. So with that, I'll kind of dive in and get us started a little bit. I apologize, we're having a little technical difficulty here with the slide deck. Just bear with me for 1 second. All right, apologize for that. We were trying something new here with the the auto cycling on the slides, so appreciate you all bearing with us as we went through that. So the big thing that we're going to talk about here is how Anderson-Negele products are specifically designed to not only survive but really thrive in the environment that we all think of in a dairy. This holds true as well in a beverage plant. A lot of these challenges that we have in the environments that we all encounter on a day-to-day basis are pretty important to consider when creating a design. So we think about the constant wash down, the idea that you have a very high humid environment, typically a fairly warm ambient air with a lot of humidity in it, cold process lines, consistent temperature changes on the process line as you go from cold products going forward. So I've got a question here from Melissa. She says that she's having trouble hearing me. Curious if anyone else is having that issue as well. So I'm hearing from others. Melissa, if you can try calling back in. and keeping your computer attached, I think that'll be helpful here. So as we talk about the challenges that we're facing in the dairy industry, a lot of the things that we do that are a little bit different. If you notice with the Anderson-Negele product, stainless steel housings are always standard. So we'll talk a little bit about why we do that with the challenges that we have. And then also that we pot our electronics, use heavy-duty enclosures, and a big piece that we're going to talk about there is using heavy-duty in the places where it counts. This idea of IP69K ingress protection, you've probably heard us talk about NEMA 4X for a number of years. We've raised the bar there and gone to a slightly different ingress protection standard. Also using the right polymers, and then the last piece that I threw in here, because it's something we don't talk about all that much, is using a different diaphragm design compared to our competition to enable our product to survive longer. So if we think about the stainless steel housing component, Anderson, if you look at the pictures that are here, the SL that's in the upper left-hand corner of this slide is a unit that came back through our repairs department. So it's seen a number of years of use. I can tell just from the electrical connector that's on there, which we stopped using here about 4 or 5 years ago. That device has been out in the field for a number of years. And then if you look at the 2 aluminum enclosures that came back through competitive returns that our repairs department has handled, the challenge here is not that you get a corroded housing or that the corrosion will go all the way through and create a pit or a hole that will allow moisture in. It's actually more that the pitted surface creates an area where a gasket or an O-ring can't seal properly. So by using a stainless steel on the housing, we're providing something that is going to stand up to the wash chemicals that are being used. So you've got a lot of high chlorine foaming agents, you've got a lot of water that's getting sprayed constantly. Aluminum does not do well with those types of environments. So moving into stainless steel is incredibly important there as we think about not only being water resistant on day 1, but on day 501 or on day 1001. So really being able to maintain the device exactly the way it was designed and tested. The next thing that we talk about is the way that we pot electronics. So the important thing to understand here, and we talked about it right at the beginning, is you have a cold process line in a very warm, humid environment. So this nice picture of lemonade with condensation forming on the outside down in the bottom left-hand corner is really to remind us what is going on with that sensor. So the enclosure, everything is at the cold temperature of what's going on inside the pipe. And you've got this warm, humid air that's on the outside and theoretically getting to the inside of the enclosure. So by using potting, what it's really doing is it's taking up some of the volume in the sensor housing. So there's less warm, moist air inside the housing that can condense eventually. This is important also in if any of that moisture does condense, the electronics are now fully encapsulated and protected. So if we think about this not only in the SL that's shown in the pictures on the slide, the upper left-hand corner is an SL before it's been potted. The lower right-hand corner shows the device after potting with the nameplate removed. The idea here is it's very important in a device, and we make the trade-off between repairability and survivability. So we make this device so, yes, it's harder to repair, but it's going to last much longer. Potting, in addition to preventing moisture and taking up volume also protects the electronics against excessive vibration. So if you think about it, all those components are being held more tightly directly onto the board, preventing a little bit of a cushion there. We take this to extremes in some of our products. Bob Kizek has most likely talked to a number of you on the phone before and probably is included in previous WebExes, discussing the fact that we pot the entire flow tube on our IZMag flow meter. So if you think about the area around the flow tube, it's a very large area of air that has to freely exchange with the environment. And by putting the potting in, we're basically removing all of that volume and making the area around the coils much, much more stable in a high humidity, condensing humidity environment. The other thing that you get as temperatures change from hot to cold is you can get a pumping action. So in addition to potting and taking up volume, which reduces the pumping action, we also would suggest using an M12 connector or another quick disconnect receptacle. What that does is it fully seals the entire electronics compartment of the device, allowing it to be able to be considerably more waterproof. The next piece that we talk about is being heavy duty where it counts. If you look at some of our legacy products were heavy duty everywhere. So if you think about the SL, part of the design specification that went into that was we knew that level sensors were being used as a step for somebody to look into the top of a tank. So part of that specification actually said it had to, when clamped to the side of a tank, accept a dynamic load from a full-size man effectively jumping on that sensor. The reason that's important, again going back to being as waterproof on day 1001 as we were on day 1, any deformation in the housing is going to impact the capability for the elastomers to seal. So if you look at the example of the E&H product on the top of the slide, they have fairly large silicone elastomers, and they're using effectively a hinged technology where they're coming in and making a seal. That seal is great before that metal is deformed. So if somebody comes in and they use that device as a step, they accidentally hit it when they come by with a cart, or heaven forbid, somebody drops it before it gets installed, that's going to start creating water ingress paths. Whereas now you take our L3 down on the bottom of the slide, and in order to make a product that is cost-effective for our customers and to be able to compete in a global market, we went to a deep-drawn enclosure, but we kept all of the sealing surfaces as solid machined. And the reason for that is now they're heavy-duty to be able to ensure that if any dents or deformations happen, it's in the part of the housing that really doesn't matter because there's no sealing constraints there. So if you think about the way that L3 housing is put together, you have 3 machined rings that get welded onto a deep-drawn enclosure. So we're taking some of the weight out of the product, which makes it easier for the customer to integrate, but we're also using a better production technology to be able to offer a more competitive price and not build so much cost in around a fully machined housing. The next piece here, for those that have been to our website more recently, you'll see myself as well as Jeff Snow and some of the product managers here at Anderson-Negele have taken to torturing our products or talking specifically about our value message in short YouTube clips. So here on the screen you can actually see what IP69K really means. So in the picture on the top left, that is a still shot from our YouTube video showing an L3 performing underwater, and the bottom right-hand corner is one of our TSB temperature transmitters performing underwater. Our goal is to make these products completely submersible, and the reason for that, when we talk about that pumping action and that condensing humidity, really the only way to keep water out of a device in a dairy plant is to make it completely submersible and waterproof. The customer needs to be able to take this device and completely drench it in water and not have any path. And we don't want it to only be submersible for a short period of time. In the case of the L3, part of the testing that we did before the product launch was we took this device and we actually submerged it in water and then put a 5 psi pressure blanket at the top to try to force water into the device and left it that way for over an hour and a half, and we're able to maintain that ingress protection through that entire time. Another piece that's important here as we think about some of our more legacy products, as we're making these improvements, we've taken something like the FH, which in the past had some issues specifically around the backplate, where we started to learn out in the field that it wasn't maintaining that water ingress protection through its full life. We changed to this 4-bolt backplate design to be able to ensure that the product will stay waterproof for a long period of time. So here in the next couple of days, you will be seeing us posting a video similar to the 2 that are up here with our FH underwater as well. The reason I bring this up is it's very important to ensure that as you're speaking to your customers, you're talking to them about the design improvements that we've made to that product so that they realize that it is more water resistant than it's been in the past. The next piece here is where we're using polymers and not using stainless steel, specifically using the right polymers to be successful with our product. So the picture on the left-hand side, this is an MPF that had been out in the field for 4 years before it came back, and we get a lot of questions around why would I use a plastic cap? You've always provided stainless. As our sensors are getting more advanced, we're able to give very good user interface experiences and give displays that are giving useful information to the operators in the environment. And part of that is giving a clear cap to be able to make it easier for the customer to see. So in this case, we choose polycarbonate specifically because it has great resistance to foaming chemicals. So if you look at the cap on that device that's been out in the field for 4 years, it's completely intact. It's effectively free of scratches. Polycarbonate is also a very hard material, so it's not going to succumb to scratching and gouging quite like what you would see. And then the other piece of this is, as we think about choosing the right thing for the right application, on our gauge crystals, we actually use a different material called polysulfone. Polysulfone is a little bit softer, but what it does better for a gauge is if you take that gauge and you're doing a steam out of place or an autoclave operation on that, polysulfone is going to be able to survive that environment, which is very important for our customers in the pharma and biotech industries. The next piece, we've talked probably pretty extensively in the past with both the MPF, the MPP, and now the L3 with the vents that we are using to be able to atmospherically compensate both our pressure and level product. We're using a hydrophobic polymer. So if you look at the picture down on the bottom right-hand side, you can actually see what a hydrophobic polymer does. So it's going to repel water, which makes it so that it's going to be able to last much better, and you're not going to get a wicking effect coming in. The water is going to want to bead up and get out of that vent rather than become trapped in it. The last piece here is we choose elastomers which are going to stand up to foaming agents. If you're not picking the right compound, what can happen is over time those elastomers can get very soft, they can become brittle, they can stretch, and you're going to lose your water ingress protection in those scenarios. So we very explicitly pick the elastomers for our ceiling fixtures to make sure that they're going to last long term. One of the other things that I'm sure you've all started to notice is we've been rolling our dual O-ring seal out to more and more of our products. And the reason for that is it provides a radial and axial sealing surface. So both the compression of the cap going down as well as the space of the cap pushing out against the side. So you get 2 points of sealing on 2 different O-rings to ensure that you truly are not only water but also airtight. Because as we discussed, that pumping action is most important on the humid air, so you want to keep the air from coming into the device. So changing gears a little bit away from really talking about housings and our more broad design methodology, I wanted to bring this into an area that's something that's not as well known with our pressure product. So talking about the way that our diaphragm is designed. And the reason that we do this so much different than others is our product was designed originally as a hygienic platform. So if you look at the competitive diaphragm design on the left-hand side of this screen, they're able to use 304 as the base metal for the tri-clamp fitting. They're only using 316L for the diaphragm, so it's a very good cost savings measure for them. The challenge is if this was on, say, a device with a going into a flanged connection where there's a flat gasket and maybe less cleaning constraints, that gasket is going to hold up much better. What happens in a tri-clamp environment is if you use an EPDM gasket to maintain 3A or be compliant with pharmaceutical regulations, you can end up getting something that after steaming or after high temperature cleaning becomes sticky. Will actually become adhered to the diaphragm and lifts up the seam weld that's shown here with the black dot. So that is a weaker weld. It's done without full penetration of the diaphragm material. So it's really just kind of tacking the diaphragm down to make sure the fill fluid's held in there. And what can end up happening over time is that diaphragm can rip. So if you look at the way Anderson develops our diaphragm, we actually weld up here at the corner. So there's 2 important things with this design. First, we bend the diaphragm into a cup before we weld it, which puts all of the flex at a bend instead of directing it at the weld. In this scenario, you're putting all of the stress directly on the seam weld in the instance on the left. On the right-hand side, all of the stress comes down to the corner here where the pointer is, which is going to make it so that the strongest part of the product is actually taking all of the flex and experiencing the strain. The other piece here is we bring the edge of the diaphragm very far in. So if you think about this as a 2-inch tri-clamp fitting, the tri-clamp gasket is going to sit right here where my mouse pointer is. It is not ever going to make contact with the diaphragm. So you're only making contact with the base metal from the elastomer perspective, which is very important because it's not going to stick and lift up and stress that diaphragm that's extremely thin and fragile. So in closing here, if we think about what this all really means to your customer, it all comes down to saving them money through longer sensor life. So we understand that we're not always the least expensive option for your customer, but what we like to think is that we're providing the lowest long-term cost of ownership for your customer. So by giving a slightly bigger investment up front, they're able to get a sensor that was designed for their environment that's truly going to last. So the important things to remember there are we're including a stainless enclosure standard and, more importantly, a heavy-duty stainless enclosure. So, and remember, the new methodology of heavy duty where it counts. So using the machined components where there is an elastomer sealing component. Also that we're potting the electronics to prevent any moist air from coming in and condensing and having any issues with those electronics. Also that we've started to go to IP69K instead of only NEMA 4X. NEMA 4X is a washdown standard. IP69K, as we start looking at discrete sensors, becomes very important because they're being exposed to rougher and rougher conditions. Important here is that we really consider the environment that the sensors are going into in every single part of the material that we choose. So it's the polymers, the elastomers, the stainless steel, making sure that all of that is going to stand up to a washdown and very heavy water and foaming chemical environment. And then the last piece there, really that diaphragm design difference is something that as you're talking to your customers and they're having challenges with gauges or pressure transmitters from other manufacturers, that would be something that you can talk to them about as a key differentiator between the Anderson-Negele design and maybe what they're using today. So with that, I will open it up to questions. While I'm waiting for some of those to come in, I thought I would explain a little bit about what the PER is going to be for attending our WebEx here this week. So as we thought about this, this is really around you guys going out and being able to articulate the difference between our product and that of our competitors and the way that it's designed. So for our L3, TS, temperature product, SL, MPF, SA, CT, and FH products, we will be sending you a PER which is good for double your standard discount on those products if you include a picture of a failed competitor's unit that you're replacing. So that could be from Anderson-Hauser, from IFM, from Rosemount. Doesn't matter who the competitor is, but show a like for like on those products and attach that with your purchase order and reference the PER number, and you will get double your standard discount. So think of that as compounding your regular discount. So for example, if you have a standard 20% discount, you would do 0.8 times 0.8, that becomes your new discount for this product. So with that, I'll pause for just a second as I start looking at some of our questions, and then we'll go from there. Thank you. So one of the first questions that I have here is around the use of the quick disconnect receptacle versus using a cable gland. So the cable gland connector or using even a conduit connector, typically we think of conduit as being this really great way to keep water out because we're threading a nice, very solid connection into the side of the device. The problem is you just created a much larger air volume and effectively a free pathway for air to exchange in and out. So we really don't like conduit connections. If you think about the water ingress protection from condensing humidity and an air exchange perspective, a quick disconnect receptacle is going to be your best protection. The cable gland would be the next best, and then conduit would actually be your worst. So as you're working with your customers, if you can encourage them, if they want to use conduit to protect a cord set, they can end that conduit section maybe 1 or 2 feet from the sensor, and then put a cable gland coming out to protect and hold the molded cord set there, come organize that in a drip loop, and then connect directly to that quick disconnect receptacle. We also have a question around field wireable connectors versus the molded cord sets. The molded cord set is going to provide a much more durable connection to that quick disconnect receptacle. The field wireable connectors typically are a little fragile. If they get hit with some of this, with someone doing some work around the equipment, they can shatter and have some issues with that. So I've got another question about some of the design upgrades. So I'll talk through a few of these. So the design methodology around machined housings has been something that we've been doing throughout effectively the entire history of the company, as has potting our electronics. But some of the specific upgrades that we've made recently, the FH 4-bolt backplate design to be able to improve the water ingress protection there it was tested out in the field in 2015 and was fully rolled out in late 2016. So if you have some customers that have had some issues prior to last year, it would be an important thing for us to go back. And if you come back to me, I would be happy to help you with a demo unit or a trial for a customer that's run into issues in the past. So you can feel free to reach out to myself, Jeff Snow, or your local RSM if you have questions with any of that. The design methodology around the dual O-ring seals and becoming more IP69K focused than NEMA 4X focused has really come on in the last 3 to 4 years. So as we've been releasing new products in roughly the last 4 years, we've been focusing a lot more, and the dual O-ring seal originated in the MPF product, and we've been rolling it into other designs since then. So I'll give us just a couple more minutes to see if we get any more questions come in. Otherwise, I appreciate everybody taking the time with us today, and I look forward to talking to you all soon. Thank you.